Hello, welcome to this video on data center automation using Cisco application-centric infrastructure. Some days ago, I got a question from some friends in F5. Would it be possible using Cisco ACI to help with this auto-scaling problem? I have a web server farm. When the servers get hot, they get a lot of load. I want to add an additional server here to help them with the load. Now eventually the load will go down again, the servers will get to normal, and then I want to remove the server I added so that everything goes back to where it was at the beginning. Typically, to do this, there are two parts, the VM part and the network part, and the network part is supposed to be more complicated. So let's have a look how difficult it is with ACI. Here we have an application modeled with Cisco ACI. We have some clients, some servers, they can speak to each other using some filters and something called a service graph. Let's have a look what's this service graph. This is implying that there is an F5 application delivery controller between clients and servers. This ADC, this big IP, is configured through ACI, so the configuration is stored here under the server's EPG. Here you can see the different parameters that are used in order to configure the big IP appliance. There's, for example, the server pool, and you can see there are two servers in this server pool. You can see the IP addresses and the ports. Port 80 is configured here. Here you can see the virtual IP address that is being used and some other stuff. If we go to the big IP appliance, to the GUI, we can see exactly this configuration has been applied by the ACI controller. The members of the server pool, the virtual servers, and everything else should be here as well. ACI is aware of the partition features of big IP, so if you have different tenants in ACI, different partitions will be created in the big IP appliance. This is one of the features that the F5 integration package with Cisco application-centric infrastructure supports. Alright, so we are ready to start. Now let's go back to Cisco ACI and let's see which steps we need to take in order to add additional servers to the pool and remove them. First thing we will do is we will turn on the API inspector. This is something that will show us which REST API calls we need to do in order to replicate something we are doing on the screen. So we will, in the GUI, add the server to the server pool and then remove it. And the API inspector will tell us which API calls we need to do in order to automate that. We need to specify a couple of things before we can edit the big IP appliance attributes. And here we go, these are all the attributes. First of all, let's go to the server pool and let's add an additional member. If you remember, there are two members now, we will add a third one. So here we click on this button there, and now we have the possibility of add a third member. We will call it S3 for server 3. Alright, now it's added, update. There you go. Now we need to add the IP address for this server. We go again to the member definition, we find our S3 server, we open it and we see the different attributes that there are to add. We have a look at S2 maybe to verify that we are adding everything, in this case IP address 3, and we put a random IP address. This is not important, we just need to see the REST call. We put the 13, for example. Alright, now we need to define the port, the TCP port to be used. Now we will add the TCP port. We will define the name of this definition, port 3, and we will say it's port 80 as the other ones. we update, and now we can go to the big IP GUI and verify that the third server has been added correctly. Let's go to the pool, to the nodes, member of the pool. There you go. There's a third server added to the pool. It's still blue because the health checks haven't verified yet whether it's up or not. Now let's remove that server. We click there, and then we have to choose the option remove. That's it. Now the server has been removed. If we go to the big IP GUI, we see it and we refresh, the server is gone. Okay, now it starts getting interesting. Now we can go to the API inspector and we can see which API calls we should do in order to exactly do the same steps once and again. ACI API is RESTful, so here you can see the URL that we have to send, the payload we have to send, and the response we should be expecting here. So there's nothing else to do but copying these API calls and pasting them in your favorite REST API client. In my case, it happens to be PO. PO is a REST client that is very useful because it can translate REST calls to programming language. Let's see whether this works. Let's send the API calls that we just pasted from the API inspector, and let's go back to the F5 appliance to see whether that's working. We refresh. There you go, the third server is there. Now let's test the REST API call in order to remove the server. Now it's there, 200, perfect. We refresh, the server is gone. So now we have the possibility of controlling the big IP appliance over ACI API. We have those calls, and now we can put them onto a nice script. So let's go to a client that has access to the virtual IP, and let's do some permanent requests. Let's start this script that will monitor the CPU of the web servers. There is some CPU load, but it's still well below the threshold that we defined. So no additional VM needs to be provisioned. Now, let's artificially raise the CPU load of one of the servers. We have here a script that will do some operation to increase the load. Now, if we go to our monitor tool, that's checking the CPU of the servers every 10 seconds. Unfortunately, it's using vCenter monitoring, and vCenter refreshes the statistics only every 60 seconds. So there is 1 minute until the monitor will realize that the CPU is higher than expected. Actually, you can see the CPU and the client is already very high because of all the requests it's sending out. But that's not the point we are trying to make. Now you can see the CPU in the servers is increasing as well. Again, before the next increase, 1 minute needs to go through, so let's accelerate this a bit. Now the 60 seconds went through, and the next check, there you go. CPU went over the threshold that we defined. It was 2000 megahertz, and now a new VM is being created. A new server is needed to be added into the server farm. So the first thing we do is adding a new VM. It's cloning that from an existing VMware template, and now it's waiting 90 seconds so that all processes in the VM start, and more importantly, so that VMware tools in vCenter is able to read the IP address that the new VMware got. So this didn't happen yet. VMware tools need some time to do that. Let's wait a bit. If we check the other VM, we will be able to see that VMware Tools did see an IP address. Let's go back to our third. There you go. So now the .16 address has been assigned over DHCP to that IP address. So we just need to wait until this 9-second timer is over, and then the server will be added into the farm. You can see here we have still the .11, .12. These were the initial servers. The .16 should be added now. So waiting a bit. There you go. So the timer is done. So now it should have already added the .16 into the list of servers. Let's refresh here. There you go. The .16 is there and it's already answering to health checks. And if we verify our client, you see that there are some 3s popping up there. So several 3s already answering to HTTP requests to the virtual IP address. Right. It was easy, wasn't it? So now what we can do is we can make the CPU load decrease. We will stop this script that was increasing the CPU load. So after some time, our CPU monitor script will realize that the load is now below the load, the threshold that we defined. So the megahertz are still bigger. We accelerate this, as you can realize. So every line are 10 seconds. At some point in time, it will go down 2000. There you go. That's it. So the VM now has been deleted and the member pool has been removed. So we refresh here, we go back to the initial 2 servers. Very easy, and you can see how easy it is to automate data center networking layer 2 to layer 7 with Cisco ACI.